Hello everyone. This is question number 15, October November 20, paper 1 2. In fact, this is very interesting question. First of all, we have to get some understanding of this question. In this question, we have a seawater here. Its density is greater than the fresh water, and this ice placed as floating on the seawater, and the cross-sectional area of this ice is 12 meters square. A beer of mass 400 kg is placed on it, standing on this ice. And definitely there is uh, some distance moved by this ice vertically downward like this one. So we have to calculate this distance. But the important thing is that when it is floating partially submerged means the partially submerged before this beer, and now it has some more submerging when more mass placed on it. Like if we have the side view of this ice, it's partially submerged like this one. But when we have a beer on it, like beer, maybe something like that. And then it is submerged up to this point. Initially, it was submerged up to this level. Now you have to get this distance. This is called D. This is required. So now it is very simple. When the ice is going to submerge up to this D, this is because of the beer standing on the top of this ice. So we can say in easy words that the mass of this beer must be equal to the mass of that water displaced. Definitely water displaced. And how much water displaced, that is equal to the mass of the beer. So we can say that the mass of this beer is equal to the mass of water displaced. Clear? It's like that. For example, if we put a stone inside the water bucket, the water will displace inside the bucket, and that mass of water must be equal to the mass of that stone putting inside the water. It's like that. So the mass of beer is 400 kg. The mass of the water displaced is equal to density into volume of water. Density of water is given, that is this thing, and the volume is equal to area into D, and the area is given as well. So 400,1020 into 12 into D. By solving this from the calculator, we can have 0.0326 meters, and in centimeter it is 3.26 cm, or you may write it as 3.3 centimeter. This one. So option B is correct. Again, a quick review that this ice is partially submerged inside the water. When the beer is standing at the top, it's submerged a little more inside, and you have to find this D. So we can solve this problem by the comparison of two masses, the mass of the beer and the mass of the water displaced. When we equate these two masses, then by substituting all the values, you can get that D. Thank you very much. Bye. Hello everyone. This is question number 4 from October November 15, paper 2-2. And this is one of the interesting questions. Look at the arrangement. We have a wall here, a beam is attached. One end of the beam is fixed at point A, it's shown. And with this beam, two loads are hanging downward. One is 4,000 Newton and the weight of the beam is 500 acting downward. There's a tension D over there. First of all, you have to get this T. So this T is perpendicular with this distance, that is 2.8, but these two forces are not perpendicular. So we have to divide these forces into the components. For example, if this angle is 30, like this one, and this angle is 30, so if we divide these forces into components, this is the perpendicular component. That is in fact the 4,000 sine 30, and this component is again 500 sine 30, because these mentioned angles are 30 degree. So this force is now perpendicular with this AB beam, and this force is perpendicular with half of the AB. So I told you earlier that the forces will always move the body towards the pivot. So this force will try to move the body in this way, while these two forces will try to move the body in this way. So these are two clockwise movements which must be equal to this anti-clockwise movement. For this clockwise movement, we must write it as, that is 4,000 sine 30 multiply with this distance, that is called moment arm, is 2.8, plus the other clockwise moments are 500 sine 30 multiply with 1.4, half of the length of the beam, is equal to the anti-clockwise moments, that is t multiply the distance is 2.8. So by solving this, we can get that the t is 2100, or you may write it as 2.1 kilonewton. This is part 1. Now part 2, we have to calculate the vertical component TV of the tension. So if we have to solve the vertical components, like one of the component of this T is this and the other component is this. If this is 60, the opposite angle is 60 as well. So this component is required because this component is vertical. This component is called T sine, sorry, it is T cos 60. Because the angle is with this component, that is why it is called T cos. So TV is equal to T cos of 60, and we know that the value of T is 2100 cos 60. By solving all these things on the calculator, the answer is written somewhere here at it 1050, or you can say this is 1100 Newton. And now moving towards this last portion, state and explain PV does not equal to the sum of the load and weight of the beam, means according to the first condition of equilibrium, the sum of upward force is equal to the sum of down. So this is the upward force, this is upward force, and these two are the downward forces. But the sum of down is not equal to the sum of up, because another force is acting at this point at A, and it's upward as well. So if we consider the force at A, then we can say that the sum of up is equal to the sum of the downward forces. Clear? So in this answer, you have to write that the sum of upward force is not equal to the sum of downward forces because another force at point A is also acting upward to make it in equilibrium. Thank you very much. This is question number 4, October, November 15. Bye. Thank you.